It is known that storms are responsible for the most drastic and immediate changes that occur along coastlines. When this occurs, sediment transport is intensified primarily in its cross-shore component. This is perpendicular to the coastline. This causes a large amount of sediment from the back beach to be eroded and deposited offshore. As we learned, a series of groins do not help to reduce the associated offshore-directed sediment transport. In principle, a series of emerged breakwaters or submerged breakwaters reduce the wave heights landward of these structures, and consequently may have the effect of reducing the rate of bachshore and dune erosion. However, due to the increase of the water level associated with a storm, the storm surge, the effectiveness of these types of structures in reducing the wave heights under storm conditions is limited. Also, wave overtopping of the breakwater segments may lead to concentrated rip currents in between the breakwater segments, and therefore quite adverse effects may occur. This is also the case for permanently submerged breakwaters. Furthermore, the use of detached breakwaters for the reduction of storm erosion may have undesirable consequences because of the inevitable impact on longshore transport gradients. By contrast, the structures that can be effective in protection of the mainland against storm-induced erosion and flooding are seawalls, revetments, bulkheads, sea dikes. A seawall is a shore parallel and nearly vertical structure at the transition between the beach and the higher mainland or dune. The seaward sloping surface of a seawall is generally impermeable, are designed to prevent coastal erosion and other damage due to wave action and storm surge, such as flooding. Seawalls are normally very massive structures because they are designed to resist the full force of waves and storm surge. A seawall is usually a fixed, unflexible structure, and therefore future sea level rise must be fully accounted for during the design phase. The philosophy behind the concept is that storm erosion will be prevented by simply cutting off the local supply of material. While in a situation without a seawall, even a moderate storm surge will attack and erode the mainland. In the situation with a seawall, this is prevented. Seawalls are often used at locations off exposed city fronts, where good protection was needed and where space was scarce. Promenades have often been constructed on top of such seawalls. Seawalls are considered a relatively easy-to-build coastal protection measure. Although there is controversy surrounding the construction of these structures, there are proven benefits and advantages to building one. A seawall is constructed at the coastline, at the foot of possible cliffs or dunes, is typically a concrete structure. It can be smooth, stepped-faced, or curved-faced. A seawall can also be built as a rubble mound structure.